We'll go to the next experiment, that is a design of JK master slave flip-flop. So to construct this JK master slave, I think you remember this concept which you have learned in flip-flop chapter. So you need NAND gate, that's a 7410 is a 3 input NAND gate, and 7400 is 2 input NAND gate. You need one 7410 and two 7400 ICs, patch cords and trainer kit. Okay, so these are the following requirements. This is the circuit which you are supposed to construct now. Look at this. This is a 7410 and this is 7410. So this is 3 inputs, 1 2 3 inputs, and this is also 3 inputs. So these two 7410 IC, these are, and 7400 7400 7400 7400. So you know that let me go to the answer. Okay, so look at here. In this is an AND gate 7400. If you use one IC, you can perform 4 operations, 1 2 3 4. Okay, similarly if you see this this and this 1 2 3 4 comes under one IC, and this 1 2 3 comes under another IC. So you need two 7400. That is what they have written. 7400 is 2 ICs, 7410 is 1 IC, 7410. So you can perform 3 operations by using one IC of 7410. So you need just two 7410 2 operations, that is 7410 1 IC and 7400 2 ICs you need. In the first IC you are supposed to make a connection with this like this shape. Now I'm just this one comes under second IC, that's a 7400. This comes under third IC 7400. So what I have done is, so this is 7410, okay, this is 7400 and this is 7400. So I have inserted one 7410 and two 7400. Okay, why do you need two 7400? Within one IC you can perform 4 operations, 1 2 3 4, but here we have 7. So 1 2 3 4 will comes under this IC, and this comes under this IC. So you need to remember these two comes under this latch, first 7410. Okay, and this 1 2 3 4. So you can notice here 1 2 3 4 5 6. This is 8 9 10 11 12 13. These are the numbers which you are supposed to search in the second 7400. And you can notice here this one 1 2 3 4 5 6 8 9 7. These 3 comes under the third IC. Okay, if you have this idea in your mind, you can able to make the connections easily. Okay, so which are the inputs here? J is an input and K is an input, Q is an output and Q bar is the output. Okay, this is what you need to give these two inputs. You need to check with these two, J, Q. I hope you people remember this table, J, K, flip-flop truth table. Okay, so you are supposed to give these two inputs and check with these outputs. Okay, so we have two inputs, J and K, Q and Q bar are the outputs, right? So let me start the connections now. Okay, as I just told, J and K are the two inputs. So J to inputs means these are the inputs, these are the outputs, right? So I'm just taking a wire. So I will make this as J, this as K, this as Q, and this as Q bar. So I'm connecting J, this is J, okay, and I'm connecting K, this is J, this is K. Okay, look at here. J is connected to pin number 2 of 7410. Pin number 2, you can see pin number 2 of 7410. K is connected to pin number 4 of 7410. So this is 7410, right? J should be connected to the pin number of 2. So I am connecting pin number 2. Okay, then K should be connected to pin number 4. So this is K. I am connected to pin number 4. Okay, so then look at here. This is 13 and this is 3. 13 and 3 are interconnected. These two belongs to one IC 7410 first IC. So 13 of first IC connected to 3 of second the same IC. So what I do? Okay, 7410, right. So this is a 14 pin ICs, NAND gates, NOR gates and NAND gates are 14 pin ICs. So this is a 14 pin. So if it is a 14 pin, 13 means pin number 13 means this is 7, this is 8, this is 9, this is 10, this is 11, this is 12, this is 13. Okay, I'm connecting pin number 13 should be connected to pin number 3. Why 13 to pin number 3? Look at here, 13 is here, pin number 3 is here. Okay, so this has to be done. Okay, then you need to remember this is a 14 pin IC. We should have forgotten to connect ground and VCC. If it is a 14 pin IC, obviously 7 should be connected to ground. 14 should be connected to VCC. Similarly with respect to all the ICs, these all are 14 pin ICs. So ground and VCC of all the three pins are connected. Okay, now I have done with input to 2 and input J to 2 and K to 4 is connected. 13 and 3 are interconnected. Okay. So this is clock. I will tell you where should the clock should be connected. Okay. So before I have left with this pin number 5 and pin number 2. I will make a connection at later. Okay, I will tell you. Okay, so look at this pin number 1 of 7410. This is 7410, right? This is 7400, 7400, 7410. Pin number 1 of 7410 should be connected to Q bar. Q bar is nothing but the output. Okay, similarly pin number 5 should be connected to Q, that's the output. So what I do is I will take a wire from pin number 1 should be connected to Q bar. This is J, this is K, then this is Q, this is Q bar. I am connecting pin number 1 is connected to Q bar and pin number 5 is connected to Q. Pin number 5 is connected to Q. Okay, so they I think almost these connections are done. 3, 4, 5, 1, 2, 13 are connected. Only we are left with this one, clock. Okay, so I will tell where the clock should be given. So where to take the connections for this clock? So there is a wire from 13 to 3 I have connected here. This is 13, this is 13. So 13 is connected to 3 here. So I have taken connection from 13 to 3. Okay. So either from 13 or either from 3, take a wire connected to clock. So I will take a wire from 13. You can take the wire from 13 or 3 either. So this wire should be connected to clock. Okay, this wire should be connected to clock. I will tell you where the clock should be given. So right now let me keep it here itself. Okay, so I will move forward now. So now this part is over. We have left with this. I will tell you where this connection has to be given. Okay, so I will move forward. I will take a connection. 12 of 7410 should be connected to 1 of 7400. 7410 is this, 7400 is this. So 12 of 7410 should be connected to 1 of 7400. Where is 12 here? Here it is 12. They have written 14, but it is 12 because there's a 14 pin IC. 12 of 7410 should be connected to 1 of 7400. So 1 of 7400. Okay. Similarly, look at this. 6 of 7410 should be connected to 5 of 7400. Where is 6? Here it is. 6 of 7410 should be connected to 5 of 7400. Where is 5? Here it is. 7410, 7400. Okay. So I have done this. Now I will go with here. 3 of 7400 should be connected to 4 of 7400. These 4 belongs to the second slot. This belongs to third slot. Okay, so when you want to make a connection from 3 to 4, that will lies in the second slot itself. So look at here, these 4 lies in the second slot. If I tell these 4 lies in the second slot, then the connection should exist within the second slot itself. Means 3 should be connected to 4, 2 should be connected to 6. These 2 connections lies in the second slot. 3 should be connected to 4. This is 3 should be connected to 4 of the same slot, because these 4 lies in the same slot. Okay. Then 2 should be connected to 6. 2 is here and it has to be connected to 6. Yeah, 6 is here. Okay, so this part 3 to 4, 2 to 6 done. So up to here is done. So let me take a connection from one more connection from 3 connected to 13 of this belongs to the second slot. These 4 belongs to second slot. Remember, I am just repeating once again. These 4 belongs to second slot. These 3 belongs to third slot. Okay, so remember 3 should be connected to 13. So already 3 has a connection. I will take one more connection from 3 connected to 13. 15 means 13 because there is a 14 pin IC. Okay. Then similarly 6 should be connected to 4. This is 4. So similarly 6 to 4. This belongs to second slot, but this belongs to third slot. This belongs to third slot. 6 of second slot connection to third slot. 6 from the second slot should have a connection from 6 to third slot 4. So where is 6 here? Here it is. So look at here, 6. From the second slot I am going to connect it to 4 of third slot. 4 of third slot. So then there is a connection. Look at here, 12 of this belongs to second slot, right? 12 of second slot, there is a connection to 5 of third slot. 12 of second slot, there is a connection to 5 of third slot. This is 12. 40 means 12. No, 14, right? 14, 15, 16, 13, 14. Oh yeah, 14. This is a 14 pin IC, right? So 14 means 12. 12 of second slot. 12 of second slot connected to 5 of third slot. Where is 5 here? 5 is here. 5 of third slot. Okay. So then this one, look at here, there's a connection from 5 to this thing. Where does this belongs to? This belongs to second slot. Look at the pin number 8. There's a 5 of third slot to 8 of second slot. 5 of third slot to 8 of second slot. So 5 of third slot to 8. This is 7, 8. 8 of second slot. Okay. Then so look at here, 10 and 9, 10 and 9. This is 10, this is 9. Both are interconnected here. Both are interconnected. This belongs to second slot. So 10, this is 10 and 9. This is 10, this is 9. Both are interconnected. Both are interconnected. Okay. So both are interconnected. So either from 10 or either from 9, take a wire, connect to clock. So I am just taking a wire either from 10 or 9. I am just interconnecting with a clock. This beginning I told you people, this is clock, not this is clock. Okay. These two wires, see, I have interconnected these two wires. So one wire belongs to this. So another wire from here. Both are interconnected, these two. One wire is taken from 13 and 3 interconnected. One wire is taken from here, this wire, and this 10, 9 and interconnected. One wire I have taken from 10 or 9 and connecting to here, these two. So these two should be connected to clock. I will tell you where the clock should be given. So I will keep it aside now. Okay. Right. So we have done up to here. Okay, up to here, almost up to here. So we are supposed to go with this now. So 11. This 11 belongs to second slot. Take a wire from 11, connect it to 1 of third slot. So 30 means 11. 11. 1 of third slot. This is 1 of third slot, 11. Okay, then similarly 6 of third slot should be connected to 9 of third slot. This belongs to third, this belongs to third, this belongs to third. So 6, this is 6. 6 of third slot should be connected to 9 of third slot. Six, 7, 8, 9. Okay. 6 of third slot, 9 of second slot. Then take a wire. So take a wire. 2 of third slot should be connected to 8 of second slot. 8 of third slot itself. These two belongs to third, right? 2 of third slot to 8 of third slot. Similarly, 3 of third slot to 10 of third slot. 2 to 8 now. This is 2, 7, 8. This is 8. 10 means 8 because it's a 14 pin IC. Okay. Then I have done 2 or to 8. Now 3 to 10. So this is 3. So 7, 8, 9, 10. 12 means 10. Okay, I have done this also. So now take a wire from 3 to output Q, 8 to output Q bar. Three to output Q. Where is 3? Here it is. 3 belongs to third slot output. Output refers to red color. So I'm taking a wire from 3 of third slot. I am connecting to Q. We already have a connection Q here. Give it to Q. Then 8 of third slot to Q bar. This Q bar belongs to output from 8, right? 7, 8, here it is. This is 8. This is 8 to, this is Q bar. This is J, this is K, this is Q, this is Q bar. So I think we did with this, everything we have done. So we have left with only clock. So where the clock has to be given now. So the final thing is this is the clock, right? So we have left with the clock. This has to be given to look at here, 1 Hertz. This 1 Hertz, okay. Once you're done with this, so you need to check the table now. You should give the input 0 0 and check what is the previous state. So whatever might be the previous state might be 0 1 or 1 0. Okay. If I make it 0 0, this can be 0 or 1, 0 1 or 1 0, whatever it might be. It all depends upon the previous state. Okay. So after that, if I give 0 1, J is equal to 0, K is equal to 1, that's a reset state. Immediately the output should be whatever might be the previous state, the output should switch to 0 1. Okay. So then after that, if I give 1 0, that's a set state. If it is in 0 1 state, immediately it should switch back to 1 0. So last state 1 1 1 is toggle, switching toggle 0 1 1 0 1 0 0 1, like it should be keep on switching like that. Okay. So let me check now. So look at here, both are 0, now it is 1 0. Okay. So it all depends upon the connections, so and IC as well. So right now it is 1 0. Okay. So now I will give 0 1. If I give 0 1 input, it should get off and it should get on. Okay. Yeah. Again went back. See, due to loose connections or Trinaket problem or something, so it happens 0 1. So now I am going to make it as 1 0 1 0. See, 1 0 now. So this is a set state. J is equal to 1, K is equal to 0, Q is equal to 1, that is a set state. So if I make it both high, that's a reset state, the last state toggle, it should be keep on, see, like this. It should toggle. It should be keep on switching automatically. Like this. Yeah. It should toggle like this. If you get the output like this, then only your experiment is right. So now it's toggling. Okay. I will move to set state. So now it is set. K 1 0 means 1 0, right? Right now it is 1 0 1 0. So I will move to the reset state now. 0 1 0 1, right? See, 0 1 0 1. So now I will off both. It should remain in the same state. So both are off. It should remain in the same state. That's the previous state. So this is how your experiment looks. So once you are done with the experiment, it will be very hard for you people to identify the mistakes if you are done. I mean the cross connection, something like that. So what you're supposed to do is you are supposed to make the connections very carefully while you're doing, and make sure that your ICs should be inserted properly. Don't press your ICs. If you press your ICs, it would be like this. See, these ICs don't work. So these are some of the damages which you people will normally do. So don't do like this. Okay, that's it about JK flip-flop.